graphing any absolute value equation, you're going to be using this formula right here. This is the standard format for how any of them would really look like. So for these types of graphs, anytime you see absolute value, these little lines right here on the sides, that means that it's an absolute value equation, and for any absolute value equation, the shapes will either be an upwards V or a downwards V. Just like over here, this is y equals the absolute value of x. This is the standard version of it without adding any transformations. This is how it should look like if you were to graph it. Anyway, let's just get on to solving this first problem. So to find the vertex of this first problem, we first look into the absolute value, what's inside the absolute value, and we see that it's x minus 2. So we set that to 0. So x minus 2 equals 0. We cancel out here on this side, and we add 2 here on this other side to solve for x, and x is equal to 2. Now to obtain the y value, we're going to plug in x into the equation. So since x equals 2, we're going to plug that in to the original problem. So this 2 is going to be plugged in right here. So if we plug that in, we see that it's now 2 minus 2, which is 0. And so now we have the absolute value of 0 right here. And what's the absolute value of 0? It's 0. So we then place the 0 right here, and it'd be negative 3 times 0 plus 4. And negative 3 times 0, what is that? That's a 0. So that we can just remove, and it'd just be 4. So the vertex is 2, 4. Now we find the 2 points. And here, since we already found that x is equal to 2 at 0, we can't use 2, but we can still use 1 and 3. If for some reason it's you get some sort of fraction, you can avoid it by trying to even go the other way, by putting in negative 1 or negative 2, negative 3. Those are the first numbers that I would use to insert for x. Anyway, so we're going to use x equals to 1. We insert 1 where the x was in the original equation. And we get here inside the absolute value area 1 minus 2. So 1 minus 2 is negative 1. The absolute value of negative 1. So what is the absolute value of negative 1? It's 1. So that would be negative 3 times 1 plus 4. Negative 3 times 1 is 3. Negative 3, sorry. Negative 3 plus 4. So negative 3 plus 4 is equal to 1. So when x is 1, y is 1. And so our first point is 1, 1. Now let's go to x equaling 3. So if we plug in 3 here, it would be 3 minus 2, which is 1. The absolute value of 1. Absolute value of 1 is 1, so then negative 3 times 1 is negative 3. Negative 3 plus 4 is also 1, just like this problem right here. So that would be 3, 1. So for this next problem, we are going to be looking inside the absolute value where we see that it's x plus 3. So since it's x plus 3, we set that to 0, and we're going to solve for x. Minus 3, x is equal to 3. And then we plug in negative 3 into the regular equation where x was. And so in here we see that the absolute value is negative 3 plus 3, which is 0. So then the absolute value of 0 is 0. So negative 4 times 0 plus 5 is 5, because negative 4 times 0 is 0, and 5 is left over. So the vertex is negative 3, 5. And now we plot our points. So I first used 1 here, and we plugged in 1 into the original problem. So 1 plus 3 is 4. The absolute value of 4 is 4. So negative 4 times 4 plus 5. First, let's just look right here. We're going left to right. Negative 4 times 4, which is negative 16. Then negative 16 plus 5 is negative 11. So our first point is 1, negative 11. Since our vertex here, we see that x is negative 3, we need to go past negative 3 on the opposite side because it's a v. It'll be a v. So let's say right here, let me see how I can do this. I'll just use this space right here. Let's say this is negative 3, 5 as the vertex. We've already gone positive, which is x being 1. So here, like on the number scale, this would be, let's say, negative 4. This is negative 2. This is 1. So on the x-axis, we've gone this way. So we've already gotten this side. We need to go this direction now. So the smallest number that we can go on this side would be negative 4. So we plug in x for negative 4. So negative 4 plus 3 is negative 1. And then the absolute value of negative 1 is 1. So negative 4 times 1 would still be negative 4 plus 5. So negative 4 plus 5 is 1. And your second point would be negative 4, 1.